All right. Hi again, everyone. Welcome to week 3 of our online learning here. To start this week off, I thought we'd keep it light without having an actual written assignment for you, but instead going over what maybe what good approaches were to the problems from that Edulastic assignment from last week were. One of the things that I got as feedback from that Google form that you completed was that some of you would like a little more explanation, a little more help with how to do some of the problems. So I wanted to take time to really break down this assessment. There was a lot of good stuff on there. Some of the things were worded slightly different than we're used to seeing, but they were all using the same concepts that we've been used to. So we'll look at each question one by one, and I'll jump over and show you how we could go about solving that one. And then after you've watched this, if you still find that you have any questions, you can send me a message on Google Classroom, and we'll see if we can't get to the bottom of things. So let's get going right away here. First up, problem 1, you're asked to find the solutions to this quadratic equation using the quadratic formula. And then they give us multiple choice answers, but really we shouldn't even worry about those right now. Let's just see what we come up with if we use that formula. So the equation is x squared minus 5x minus 14 is equal to 0. And right away we want to be thinking, okay, what are our a, b, and c values that we're going to plug into the quadratic formula? So a always comes in front of the x squared term. There's that hidden positive 1 there, so that'll be a. B is in front of the x term. It's 5, but it's also subtraction, which is the same as adding negative 5. So b is actually negative 5. And then c, same idea. It's subtracting 14, so it's actually negative 14. Remember, the quadratic formula works to solve the x-intercepts or values of x when the equation is equal to 0, because when y is 0, that puts us on the x-axis. So now that we have a, b, and c, we can plug those into our quadratic formula. Just a reminder what that is. So when we're solving, it says that x will be equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. And then all of that is over 2a. Since we've already identified a, b, and c, we need to carefully plug those values in and then make sure we carefully follow the order of operations. So as we do that, we'll see that x is equal to negative 5. It'd be fine to just jump right ahead and put positive 5 there, but we'll start with that. And then we're taking the square root of b squared, so negative 5 squared minus 4 times a, which is 1, times c, which is negative 14. And then that's all over 2 times 1. So right away, my suggestion would be try to do all the simple math you can to make this look a little bit easier. So we'll see that x is equal to positive 5 plus or minus the square root. Well, negative 5 squared is positive 25 minus 4 times 1 times negative 14. Well, 4 times 1 is 4 times negative 14 is going to give us 28 and 56. So 25 minus 56 in our square root. That's all over 2 times 1, which is just 2. All right, so we've got things looking pretty simple, but I identify a problem right away because I see 25 minus 56, which lets me know I think I made a mistake because that'll give me a negative that I can't take the square root of. So if I look back, subtraction is here, and there's also a negative 14. So I'm actually subtracting the negative 56 I get from multiplying 4 times negative 14. So minus negative 56, which is the same as adding. And that's an important thing to catch. That's a common mistake that we can make there. So with that correction, let's simplify things even further. So x will be equal to 5 plus or minus the square root. If we add 25 plus 56, that gives us 81, which is good news there since we're taking the square root. And then that's all over 2 still. Let's jump down to another page. So we had x was equal to 5 plus or minus the square root of 81 all over 2. We know the square root of 81, so we can say x is equal to 5 plus or minus 9 all over 2. At this point, we need to split up into two equations, so we'll see that x is equal to 5 plus 9 over 2, and then separately, x is equal to 5 minus 9 over 2. If we solve those out, we get 14 over 2, or 7. And then here we get negative 4 over 2, or negative 2. So that tells us our answers for x, or our solutions, are 7 and negative 2. If you go back and look at that assessment, that was that first choice. X was equal to 7 and negative 2. So that's just a matter of using the quadratic formula. You'll notice we didn't even need a calculator as we went through that problem. That's not always the case. We got lucky that the square root of 81 showed up in that problem because it made it simple to work with, so we didn't need to do any kind of calculator work. All right, our next problem told us to select the solutions to this quadratic equation. Again, those solutions are like the x-intercepts, because that 0, which I wish I could circle but I can't, that's where y would be, so that's indicating we're on the x-axis, we're finding x-intercepts. Well, to get our solutions, let's take that quadratic x squared minus 6x plus 8 and see what we can do with it. So if we work with x squared minus 6x plus 8 is equal to 0, our first step should be factoring to see if we can get actual factors and solve from there. So I put x squared in one corner of my rectangle and 8 in another. When I multiply those across, I get 8x squared. That's the top of my diamond. And then negative 6x goes in the bottom. So factors that multiply to 8x squared and add to negative 6x would be negative 4x and negative 2x. So we're lucky that works out. We fill in the rest of our rectangle, and now we take some greatest common factors. So I know we're doing x times x to get x squared, and then between 8 and negative 2, I'll take out negative 2. Between negative 4 and 8, I'll take out negative 4. So our factors are x minus 4 multiplied by x minus 2, and those will be equal to 0 because they're replacing the left side of the equation. Those are equivalent. Now we use that zero product property, which says when two things multiply together to give you 0, one of them has to be 0. So x minus 4 could equal 0, or x minus 2 could equal 0, and that means x is equal to positive 4 and x is equal to positive 2. So those are our solutions. If we go back and check, sure enough, I see x equals 2 and x equals positive 4 as our first two choices, so we should select both of those. All right, next up, factor the following expression. That's going to look pretty familiar to what we just did. So it's x squared minus 15x plus 56. X squared minus 15x plus 56. They didn't tell us to solve. We're just breaking it down into factors, and we'll use that rectangle and diamond structure to do that. So if we put x squared and 56 in our corners, that gives us 56x squared, and then negative 15x goes in the bottom. So to multiply to positive 56 and add to negative 15, I think we're going to be working with negative 8 and negative 7, and then we'll need our x's to make that work out. So we've got what to plug in here, and then we just take out our greatest common factors again. So that means we'll take out negative 8 and we'll take out negative 7. Our factors are x minus 8 multiplied by x minus 7. And that's all we had to do for that problem. We didn't have to go further to solve. We were asked to factor another one. This one, believe it or not, you didn't actually need the generic rectangle if you recognize that you had the difference of two squares there. Anytime we see that, in this one we had 16x squared minus 25, I know right away that we'll take the square root of each term and put that in. So I'll have 4x in both parentheses and I'll have 5 in both parentheses. One will be added, one will be subtracted, and those are our factors right away. You could check that by multiplying them in a generic rectangle. If you don't recognize the shortcut, you can use the generic rectangle and diamond to factor, but the shortcut's nice because we could get that answer right away. All right, moving along, multiplying binomials. This is another task for the generic rectangle, so we'll put x minus 7 and x plus 3 on the outside of a rectangle. So x minus 7 and x plus 3. And not that it matters, but actually I'll flip that so that it appears the same way we've been factoring. So x times x will give us x squared. 3 times x will be 3x. Negative 7 times x is negative 7x. And 3 times negative 7 is negative 21. So that tells us we have x squared minus 7x plus 3x minus 21. And if we combine like terms, that gives us x squared minus 4x minus 21. So that would be what it looks like when we multiply that binomial. All right. Now, on to the next problem. This one asked us to graph a function, and we were given 4 choices. Although I'm having a little trouble scrolling through on my iPad. But that's okay. We don't need those anyway, because right away when I'm thinking about graphing, I want to be thinking about, okay, what's the y-intercept? What are the x-intercepts? And what is the vertex? So getting those key points will make it really easy to determine what the graph should look like. So we have 4x squared minus 8x plus 7. 4x squared minus 8x plus 7. And that was f of x. They could have used y as well, but it's written with function notation here. It doesn't change our process. So to get the y-intercept, remember that's the value when x is 0, so that we're on that axis. By putting in 0 for x squared and 0 for x, those cancel out completely, and we're left with 7 as our y-intercept. So the y-intercept is 7. Believe it or not, that was actually the only thing you needed to be able to identify which graph matched this, because only one of them had a y-intercept of 7. You could keep going, though, and to continue, you would be thinking, okay, how can I get my x-intercepts, or values when y is 0? So you'd be solving 0 is equal to 4x squared minus 8x plus 7. That's when we can try to factor first, and if that doesn't work, then we have to move on to another method. If we look at factoring, so we'll put 4x squared in a corner and positive 7 in a corner. So we're working with 28x squared and negative 8x. So we have to think, okay, factors of 28 that add to negative 8. Well, 28's factors, 28 and 1 won't do anything. 14 and 2, there's no way we'll get to negative 8. If we look at 7 and 4, again, I don't think we're going to get to negative 8 that way, which makes me think we might not be able to factor this one. That moves us on to something like the quadratic formula, which you can go back to the first problem to look at how to do, and completing the square, which we'll be doing in just a moment here. So those are other methods you could use, but ultimately you didn't need them because that y-intercept was all you needed. All right. Back to factoring, x squared plus 9x plus 14